fundamental area of chemistry. And it's basically, oh, lean is here. And chain is here as well. Okay. So yes, in this chapter we'll be dealing with an area of chemistry which is called stoichiometry. Stoichiometry is basically that area in chemistry which deals with the quantitative relationships between substances involved in a chemical reaction. And you're going to see that a lot of things that we learned earlier in terms of nomenclature, in terms of balancing equations, all that stuff will all come into play when it comes to stoichiometry. All right. So let me use a simple example before we actually get into these questions. So let's say you're given get rid of all this here. Okay, so let's say we have an equation. Oh, this would help. Okay, so let's say you have this reaction. H2O to form H1O2. All right. And to balance this, we have 2 here and 2 here. All right. So let's say we want to figure out how much of, let's say, hydrogen that is produced for a certain amount of water, right? We can do that because we have the coefficients for hydrogen and water in this equation, which makes the equation balanced, right? So based on what we have here, we can say that 2 moles of hydrogen, of water, would be equivalent to 2 moles of hydrogen, right? So basically, if you're given, let's say, 0.5 moles of water, the question is how many moles of hydrogen will be produced? Well, that's easy because it's a 1-to-1 ratio between those two. So what you can do is multiply by a conversion factor, which represents the relationship between these two. So you're going to put 2 moles of hydrogen. Oh, I made a mistake here. There should be hydrogen here. Okay, so 2 moles of hydrogen over 2 moles of H2O. This will cancel out with that, and your answer would be 0.5 moles of hydrogen, right? So that's just a relatively simple example of the type of calculations we'll be doing this chapter, all right? So several things are important, which I need to stress when it comes to doing these problems, right? And that is basically this. You must start off with a balanced equation. If the equation is not balanced, then all subsequent calculations are suspect, right? You could end up with the right answer, but that would be purely by accident, right? So if you want to ensure that you get the correct answer, you have to start off with a balanced equation, all right? There are some other things that are important as well. It's important that you recognize that the coefficients here represent the mole relationships between the different substances, not the mass relationships. So if you're given a question where you're given the mass of one substance, let me do this here. If you're given a mass of, let's say, 90 grams of water, 90.0 grams of water, and you want to find out how many grams of hydrogen will be produced, then what you'd have to do first is start out with the 90.0 grams of water, convert that to moles, so that will be 1 mole of H2O, and the molar mass of water would be 18.02 grams of H2O. And then you'd have to look at the mole ratio between the hydrogen and the water. That will be 2 to 2. So here I'm going to put 2 moles of hydrogen above. Down here I'm going to put 2 moles of H2O. So the units that will cancel out so far are these right here. And then now to get the mass of water in grams, you'd have to use the molar mass of water, which is 1.008 grams of H2O per mole. From H2 per 1 mole of H2. So this will cancel out with that. And then we do the number crunching, 90 divided by 18.02 times 1 times 1.008. So according to my calculation, this works out to be 15.03 grams of H2. So these are the kind of calculations that we'll be dealing with in this chapter. All right. So with that said, let me get to the assignment. So this question, as I said before, in order for you to do these calculations correctly, you have to ensure that the equations are balanced. So as stated here, some of the equations are not balanced, so make sure that you balance them before you answer the rest of the question, all right? Now, the first one is actually balanced, so we don't need to balance it. And the question says, how many grams of sodium sulfate will be formed if you start with 200 grams of sodium hydroxide, right? So they gave you the balanced equation. They gave you the mass of sodium hydroxide, and you're asked to find the mass of the sodium sulfate. So what I would do is start off with the 200 grams of the sodium hydroxide, all right? And if you remember the example I just worked, then you should realize that the first step in this process would be to convert from grams to moles. So this is going to be 1 mole of sodium hydroxide above. And if I remember correctly, the molar mass of sodium hydroxide is 40.00 grams sodium hydroxide. And then the next conversion factor will be expressing the mole ratio between the sodium hydroxide and the sodium sulfate. So that's a 1 to 2 mole ratio. I'm going to put 1 mole of sodium sulfate above and 2 moles of sodium hydroxide below. So this will go with that. And then the last step in this process is multiplying by the molar mass of sodium sulfate. And let me see if I can use my molar mass calculator. Okay, so let's see here. Okay, so 142.04 is the molar mass of sodium sulfate, 142.04 grams of Na2SO4. And then we do the number crunching. So that will be 200 divided by 40 divided by 2 times 142.04. And round it off to 3 sig fig, that becomes 355 grams of sodium sulfate. And that's it. That's how that is done. All right. Any questions about this one? Any questions? Any questions on the Zoom? All right, let me clear this. And scroll down. Okay, so if you understood what we did in number 1, you should be able to do number 2. Again, they gave us a balanced equation. And in this case, they're asking for how many grams of lithium nitrate. So this is the lithium nitrate right here. Will be needed to make 255 grams of lithium sulfate, assuming that you have an adequate amount of lead for sulfate to do the reaction. Okay, so let me hear what you have to say about doing this particular problem. How would you go about solving this problem?
Start with 255 grams of lithium sulfate.
Okay, so 255 grams of lithium sulfate. And what do you multiply that by?
1.
Hmm?
Put 1 more on the top.
1 mole of lithium sulfate above, and below would be the molar mass. Let me use a calculator for that. So lithium sulfate. Okay, so 109.4 is what I got here. 109.4. 0.94, I'm sorry, 94 grams of lithium sulfate. Okay. So the next step is what?
You put 4 moles of LiNO3 on the top.
Okay, so 4 moles of lithium nitrate above, and what goes below?
And 2 moles of lithium.
2 moles of lithium sulfate below. Okay, so this unit would cancel with that. This unit would cancel with that. So the next step would be what?
The molar mass of LiNO3.
Okay, let me do that one. LiNO3. Okay, 68.95. So that would go
On top.
on top, 68.95 grams of LiNO3, and below would be the molar mass. I'm sorry, would be, what am I saying? 1 mole of lithium nitrate. So all we have to do now is to punch some numbers with our calculator. 255 divided by 109.94 times 4 divided by 2 times 68.95. So according to my calculation, I have to roll this off to 3 sig figs. So that means that the answer will be 320 with a decimal point here. And that would be grams of lithium nitrate. That's it. All right. Yes, sir.
Will you mark this wrong if we don't add the decimal point?
I'll probably take off half a point. Because the final answer must be expressed to 3 sig figs, right? So you have to indicate that 0 is significant by putting a decimal point in. Okay, any other question about it? Any other questions? Excuse me. All right, so let me see here. What's next? Let me clear this. Go down. Okay, pretty much the same kind of question, but this time the equation is not balanced. So please, when you're doing this question, and for all the questions after this, make sure you check that the equation is balanced. If it's not balanced, then you balance it first before you do the rest of it, right? So I'm going to leave this for you to do. Basically, it's similar to the first 2 questions that we just looked at, right? Let me see here, number 8. Number 4. Same thing for number 4. Again, make sure that the equation is balanced. I'm going to leave that for you to do. Number 5, same thing. Number 6. Number 7. 8. Number 9. Number 10. So all of these you should be able to do. All of these you should be able to do. If you have any problems, feel free to come by my office or give me a call, and I'm more than willing to help you. Let me see here. Okay. All right, now we're going to get into a discussion of the concept of limiting reactant. All right. And I spent some time in the video discussing this concept. I think I used the example of somebody manufacturing bicycles, right? So if you follow the logic, basically what you'll find is that if you're given a certain amount of items to make 1 unit of bicycle, you can figure out basically the maximum amount of bicycles you can manufacture. But based on the amount of different items, I think it was like what, 2 wheels, a frame, and a pedal assembly, right? You might have some items left over. I don't remember exactly what the items are. but you're gonna have some items left over, but one of the items will be completely used up. So the item that is completely used up, that would be the limiting item. And that item will determine how much product you can get, the maximum amount of product you can get. While the other items which are left over, those are the excess items, right? And the amount of product is not dependent on those. It's only dependent on the limiting item, right? So we can apply that to chemical reactions such as the one that we have here. So let's look at this question, number 12. Gives you the balance equation, and it says if you have spilled 6.3 moles of hydrochloric acid and put 2.8 moles of calcium hydroxide on it, which substance is the limiting reactant? All right, so the way you go about figuring out which is the limiting reactant is you start off with each reactant. So I'm going to start off with the hydrochloric acid, 6.3 moles of HCl. And based on that, you can determine how much of the product you expect to get, right? So I'm going to focus on this as a product. You could focus on this as well, but I'll be focusing on the calcium chloride. So I would look at the mole ratio between the calcium chloride and the hydrochloric acid. And you can see it's a 2-to-1 ratio. And the way that I would express that here is that I would put 2 moles of HCl down here and 1 mole of CaCl2 above. And when you work this out, 6.3 divided by 2, that gives you 3.15 or 3.2, round out to 2 6 3.2 moles of calcium chloride. All right. And then I do something similar, but this time starting with 2.8 moles of calcium hydroxide. And again, I would focus on the calcium chloride as a product. So I would look at the mole ratio between the calcium chloride and the calcium hydroxide. That's a 1-to-1 mole ratio. And the way I'll express that here, I'll put 1 mole of calcium chloride above and 1 mole of calcium hydroxide below. This will go with that. So therefore, you're going to end up with 2.8 moles of calcium chloride. The next step is that I'll compare these two numbers, this number and this number. And I'll ask myself, which one is the lower value? And the answer, of course, is that this is lower. Right? And because that is lower, that means that the calcium hydroxide would be the limiting reactant. And that's it. That's how you determine which reactant is limiting, right? You start off with each reactant. Based on the amounts, you're going to calculate how much of a particular product you expect to get based on each of them. The one that results in the lower amount of product, right? That reactant would be the limiting reactant, right? So therefore, you'd expect to get, when you do this reaction, 2.8 moles of calcium chloride, all right? Yeah, so that's it. That's the answer for question A, because question A is just asking for the limiting reactant, all right? Okay, any question about this one? Any questions? Any questions? Any questions? Okay, there it is. So, okay, now here they're asking how many moles? I should have erased. Hold on, let me see if I can retrieve. I shouldn't be too quick to. Okay, good. All right, so let me scroll. This question is asking how many moles of the excess reactant remain, right? Now, we know that the calcium hydroxide is a limiting reactant, right? So to answer this question, what I would do is, based on the limiting reactant, I would figure out how much of the excess reactant will react with this much of the limiting reactant. And then once I find out how much of the excess reactant reacted with the limiting reactant, I'd subtract that from the original amount of the excess reactant. So what I'm going to do is, I'm going to start off with the 2.8 moles of the calcium hydroxide, because that is the limiting reactant. And then I'll look at the mole ratio between the calcium hydroxide and the hydrochloric acid. So if you look at the equation, you'll see that the mole ratio between the calcium hydroxide and the hydrochloric acid is 1-to-2. Just check something here, right? So what I would do is multiply this by 2 moles of HCl above and 1 mole of calcium hydroxide below. So this gives you 5.6 moles of calcium hydroxide. Now remember, this is the amount of calcium hydroxide that reacted, right? What the question is asking for is how much of the excess reactant, the calcium hydroxide, I'm sorry, not HCl, not calcium hydroxide. What's wrong with me? This should be HCl. All right. So that represents the amount of HCl that reacted. Now the original amount of HCl is 6.3 moles, right? The question is asking for how many moles of the HCl remains. So therefore, moles of HCl remaining would be the original amount, which is 6.3 moles, minus the 5.6 moles. And that will give you 0.8. 0.7, sorry. No, what am I saying? Yeah, 0.7 moles of HCl remaining, all right? So that's basically how that is done. So this will be the final answer for the B part. All right, any questions about this? Oh, here you go. Everybody got a copy of the assignment, right? Careful. School is broke. Yeah. Look forward to your film. Read some part of you. All right, okay. So if you understand this, let's see what's next. Let me clear this. Okay, now in this case here, let's see here. Oh, this is another limiting reactant problem. Okay, so they gave you the balance equation and they gave you 0.048 moles of aluminum and 0.030 moles of oxygen. And it's asking what is the limiting reactant. Okay, so let's hear what you have to say. If you understood what we did in the previous question, this should be a brief, all right? So what's the first step? Yes, sir.
I would take 0.048 moles of Al,
Mm-hmm.
and then I would multiply it by 2 moles of Al2O3 over 4 mole Al.
Okay, hold on. 4 moles of Al. And work that out, right? So that gives you 0.024, right?
Yep.
Moles of Al2O3. All right, what next?
I would take 0.030 moles of O2,
Mm-hmm.
and then I'd multiply it by 2 mole Al2O3
Okay.
over 3 mole O2.
And 3 moles of O2. And that gives 0.02, right?
Yep.
0.020 moles of Al2O3. Okay, what next?
And so the limiting reactant is O2.
Exactly. This is the limiting reactant because this is less than that, right? The 0.020 is less than the 0.024, so therefore the O2 will be the limiting reactant. All right? Any questions about this one? Any questions? Any questions out there in Zoom? Any questions? Okay, let me clear this. Let's scroll down. Oh, the B part. Same idea. In fact, as in the case of the B part in the previous question. How many moles of the excess reactant? Okay, so let me see if I can bring this back. Okay. How many moles of the excess reactant remain? All right, so let me hear what you have to say about answering that question.
0.030 moles of O2.
Okay, 0.030 moles of O2. And what do we multiply that by?
2 moles
2 moles of
Al2O3.
Al2O3. And what goes below? moles of O2, very good. So this gives you 0.020, right? Moles of Al2O3. What next?
You take that minus, you take 0.030 minus 0.022.
So moles of okay, I lost that place here. So it's oh, okay. So it's moles of, oh, wait a minute.
It's supposed to be yeah.
It's supposed to be Al, right?
Or
Yeah.
AL, yeah.
Okay, hold on. Yeah. Ah. Should be 4 moles of Al. Up here, my bad. Oh. So this should be 4 moles of Al. Above. 4 moles of Al. So this should be something different. So that's 0.040, right?
Yeah.
0.040 moles of Al. All right, so remember now, this is the amount of aluminum that reacts, right? What the question is asking for, how many moles of the excess reactant, which is aluminum, remains? So moles of aluminum remaining would be equal to what?
0.0 moles minus 0.020.
Nope.
No, 30.
Mm-mm.
0.024 minus.
Remember, this is the amount of aluminum that reacted, right?
0.048
Exactly, 0.048 moles.
minus
That's the original amount of aluminum minus,
0.040.
exactly. So that will give you 0.008 moles of aluminum remaining. All right? And that's how that is done. All right? Any question about this one? Any questions? Okay, let's see here. That was number 13. Do this. Scroll down. Okay, now in this case, let me see here. Now in this case, it's the same question or same type of question, but you have to make sure that the equation is balanced. So I'm gonna leave that for you to do, all right? Let me just check this here. Right, so they gave you the moles of zinc sulfide, they gave you the moles of oxygen, and you have to find out which is the limiting reactant. So basically what we did in the previous 2 questions, it's the same idea, but make sure that you balance the equation first. I'm gonna leave that for you to do. And they're asking for the moles of the excess reactant again, so same idea as before. So let me move on now to question number 15. Now in 15, they gave you the equation, and the equation is not balanced. So let's do that first. How will you balance this equation?
Uh, 2121.
I would agree. So 2, 1, 2, 1. Okay, good. Now the question goes on to say in the A part, when 0.855 grams of chlorine and 3.205 grams of KBr mixed in solutions, which is the limiting reactant? So it's asking the same thing, but the difference between this question and the previous questions is that they did not give you the moles, they gave you the masses of the reactants, right? So basically what you have to do is, in each case, add an extra step, because what you have to do is convert each of these masses to moles, right? And then you find the moles of the product. And the product we can focus on can be the potassium chloride or the bromine. So in the case of the 0.855 grams of chlorine, I'm going to start off with that here. And the first thing I would do with this is to convert that to moles, right? So up here, I'm going to have 1 mole of chlorine. And below here, I'm gonna have the molar mass. Chlorine is 35.45 times 2. So this is going to be 70.90 grams of chlorine. All right. So this will go with this. Then I will look at the mole ratio between the chlorine and any one of these two products. It doesn't matter which one. I'm going to choose the potassium chloride, right? So it's a 2-to-1 mole ratio between the potassium chloride and the chlorine. So that would be represented here as 2 moles of potassium chloride above and 1 mole of chlorine below. And then I will work that out. So 0.855 divided by 70.90 times 2. And according to my calculation, rounded off to 3 sig figs, that's going to be 0.0241 moles of potassium chloride. All right. So that's as far as that is concerned. Then I'm going to do something similar, but this time starting with 3.205 grams of potassium bromide. And like I did before, I'll convert from grams to moles. So above here, I'm going to have 1 mole of KBr. And below, the molar mass of KBr. So I'm going to do that thing. Okay, so according to this here, the molar mass of KBr is 119.000 grams of KBr per mole. All right, so that's the molar mass of KBr. The next step is going to be similar to what we did in the previous series. So now I'm going to look at the mole ratio this time between the KBr and the KCl. And you can see it's a 2-to-2 mole ratio. It's the same thing as 1-to-1. So 2 moles of KCl over 2 moles of KBr. And then I would work this out. So 3.205 divided by 119 times 1. So that will be equal to, according to my calculation, 0.0269 mole of KCl. Okay, so based on what we have just done, which of the two, the chlorine or the KBr, would be the limiting reactant?
Chlorine.
The chlorine, exactly, because this is lower than this, which means that this is the limiting reactant. All right, and that's it. So that's the answer for the A part. All right, any questions about this? Any questions? Nope. Okay, I won't make the mistake of deleting this, so let me scroll down because I suspect. Oh, yes, I do need information from this part to answer the B part. So let's go down to the B part. This is here. Okay, so down here is the A part, right? That's A part. Okay. So for the B part, it's asking how many grams of each product are formed, right? So that's relatively easy because for one of them at least, because we know that between these two numbers, this would be representing the one amount that you'd expect to get as far as the KCl is concerned. So all you have to do to get the mass of KCl, potassium chloride, that would be equal to the moles, 0.0241 moles, multiplied by the molar mass. So again, I have to use the calculator here. KCl, oops. And 74.55 is the molar mass. (74.55 grams) would be the molar mass of KCl. So 0.0241 times 74.55. So according to my calculations, the mass of the KCl that will be formed will be 1.80 grams. Then roll it off to 3 6 right? So that part is the easier part, the mass of the potassium chloride. The one that is slightly more challenging is to get the mass of the bromine, which is the other product. Right. So basically, what we have to do is start off with the limiting reactant, which we already established is 0.855 grams of the chlorine. Convert that to moles. 1 mole over 70.90 grams of chlorine. And then the next conversion factor is where we look at the mole ratio between the chlorine and the bromine, which will be a 1-to-1 mole ratio. So we're going to have 1 mole of Br2 above, and 1 mole of chlorine below. And then we multiply this by the molar mass of bromine. So let me go back to my table, not table, my calculator here. So bromine, Br2, calculate. And 159.81 is the molar mass of Br2. So I'm going to put that here, 159.81 grams of Br2 over 1 mole of Br2. So I'm sorry,
7459.81.
is that what?
The grams of bromine.
159.81. All right. So let's do the calculation for this. So 0.855 divided by 70.9 times 159.81. And I got, and please correct me if I'm wrong, but I got 1.93 grams of bromine. All right, so this is for potassium chloride, and this is for bromine. So that answers the B part. All right. Any questions about this? Any questions? Any questions? All right. Let me clear this. And scroll down. Okay. Let me see here. Number 16. Of course, it's bear with me. Okay, so again, I think you have to make sure that this equation, I don't think this equation is balanced. You have to balance it. And they said what mass of Z or say can be produced. Okay, so it's the same thing as in the previous question. So I'm going to leave that for you to do. But again, check each of these equations and make sure that they're balanced. If the equation is unbalanced, then that increases the likelihood that you'll end up with the wrong answer. Let me see here. What next? Okay, this is the same thing, same type of thing. And again, this equation is not balanced. So again, you have to make sure that the equation is balanced. So I'm going to leave that to you to do as well. Oops, all right. Okay, again, this equation is not balanced. Oh, so this is dealing with, okay, let me deal with this one. So this is dealing with the concept of yields. You have 3 types. You have actual yield, percent yield, and the theoretical yield, right? Now, the theoretical yield is basically the amount of product that you expect to get when you do the reaction based on the amount of reactants that you start off with. So all the examples that we have looked at before, right? Where you're given a certain amount of this reactant, a certain amount of this reactant, and you determine which one is limiting reactant. Remember now, the limiting reactant is what determines the amount of product that you expect to get. Now, in practice, what you'll find very often is that if you were to actually do the experiment and isolate the product, the amount of product that you'll get in practice is very often less than what you expect to get, right? So that is the difference between what is called the theoretical yield, which is the amount of product you expect to get, and the actual yield, which is the amount of product that you actually get, that you get when you isolate the product, right? So, if you look in, chemical literature, especially when it comes to, research that is conducted and published in journals, routinely, they will give information about the percent yield, right? Because the percent yield is basically a measure of how successful the reaction is in terms of product outcome, right? Most reaction gives you low yields, right? If you do a reaction and you end up with a percent yield in the 90s, you're doing very, very good. That's exceptional, right? Most percent yields are usually about 50, 60% or even low, all right? So that's the actual yield and the theoretical yield. The percent yield is basically the ratio of actual yield divided by the theoretical yield times 100%, right? So that's basically how you calculate the percent yield, all right? So with that said, in the case of question 18, they gave us a balanced equation. I'm sorry, they gave us an unbalanced equation. So let me balance that now. So how do we go about balancing this equation? How do we balance this equation?
Is it 2322?
Two what?
2322?
I think you're correct. Let me just check and make sure. 2 zincs, 2 sulfurs, 6 oxygens. Yep, okay. So that's a balanced equation. So the question says, if the typical yield is 86.7%, so that's percent yield, how much sulfur dioxide should be expected if 4.897 grams of zinc sulfide are used, all right? So let me scroll down. So what I would do here, so this is 2, 3, 2, 2. Okay, so you're starting off with 4.897 grams of zinc sulfide. All right. So what I would do is I would look at the mole ratio between the zinc sulfide and the sulfur dioxide. But first, I'll convert to moles. So 1 mole of zinc sulfide would be above, and then the molar mass I need to get. So let me go to my molar mass calculator here. So zinc sulfide, ZNS. So that is 97.46 grams per mole. So I'm going to put that here, 97.46 grams of zinc sulfide. All right. And then I'll look at the mole ratio between the zinc sulfide and the sulfur dioxide, which is a 2-to-2 mole ratio. So the way I represent that here is that I'm going to have 2 moles of SO2 and 2 moles of zinc sulfide. And then I would, let me see, how much SO2. Okay, now in this case, they didn't specify the amount that you should express it in terms of either moles or grams, right? I'm going to assume grams, but if you stop here and calculate the moles here, I would have no problem with that. But I'm just going to go all the way to grams, right? So that means that I'm going to put 1 mole of SO2 down here, and up here I'll put the molar mass in grams, which is SO2 64.06. So that would go right here, 64.06 grams of SO2. All right. So with that said, let's do the number crunching. So 4897 divided by 97.46. Multiplied by 64.06. So according to my calculation, this works out to be equal to 3,219 grams of SO2, right? Now this, folks, is the theoretical yield. That is the amount of product, the maximum amount of product that you'd expect to get, right? What the question is asking for is the actual yield, right? So remember I said here that the percent yield is equal to the actual yield divided by the theoretical yield times 100%. So that means that the actual yield would be equal to the percent yield times the theoretical yield divided by 100%. All right. So basically that would be 86.78% times the theoretical yield, which is 3,219 grams, all divided by 100%, and that will give you the answer. So that would be so according to my calculation, this works out to be 2,793 grams. That would be the actual yield. All right. Okay, any question about this one? Any questions? Questions? No questions? All right. So that's as far as that is concerned. Let me clear this. Scroll down. Okay, so I'm gonna leave this one for you to do. Again, you have to balance the equation. This one is not balanced. So you have to balance it. So make sure you balance it. And then you should be able to do this one. This is similar to ones that we have done before. Let me look at the B part here. Yep, so you should be able to do that. Let me see this one here. Okay. Let's say. Okay, you should be able to do this one. Number 20. Look at number 21. Okay, so this is definitely not balanced. So again, you have to balance it before you can do the math part of it. So I'm gonna need that for you to do. And then that's a percent yield, so you should be able to do that as well. And let me see, number 22. Okay, so in this case, they give you a series of amounts of different substances. And you're to calculate the percent yield in each case. Okay, so you should be able to do that as well. And that, believe it or not, is it as far as this is concerned. So if while doing these, if you have any issues or any problems, feel free to contact me, and I'll be more than willing to help you. Before you leave, so your next test. Let me see here. According to the syllabus. Is the week of the 23rd, which is after the break. The break is next week. What I'm gonna do is, I'm gonna put that up until the 30th, the week of the 30th, right? So not the week of the 23rd, the week of the 30th, all right? Now, in terms of the topics that will be covered by this test, hold on, I should have closed that. What was the last test? What topics were covered by the last test?
Was it want to destroy any?
Yeah.
That was versions.
Okay, so 1 through 3?
Yeah.
And we're at assignment 1 now, 9? 1 through 3. Okay, I think I'll have mercy on you guys. And I'm going to make the test be based on chapters 4, 5, and 6. Right, so 4, 5, and 6 will be the chapters covered by your next test, which will be given during the week of what did I say? Week of the 30th.
The dirtiest, so
Right.
it's Monday through Friday.
Monday through, right, just like last time, Monday through Friday, sign up in the testing center and we do it then, right? Okay, let's get over here, too hot.
Yes.
What were you gonna attend? Oh, let me set up the, what's your name?
Olivia
Olivia, what's the last name?
Warren, WARR.
Oh, Warren, okay. Let me set the, due date for this assignment,
It's Friday, right?
what's that?
Thank you, Friday.
Yeah, I guess I could do that, but let me, make sure. Okay, so. Today is the 10th. Yeah, I'll make it Friday. So let me do this. And then let me do, so today is the, oh no, wait a minute. That's last year.
Oh, did you not publish it for the PowerPoint people? Not PowerPoint, the Zoom people?
What, the assignment?
Yeah,
I thought I did. Well, I can check and make sure, but I thought
I thought so too, but
okay, so the 13th. All right, and let me just check here, since you said so. Assignment number, yes, it's published. Yeah. All right, so that will be due on the 13th, which is Friday, I think it is.
what do you think you're my first time assignment screen? I sent it to you a couple weeks ago.
Oh. Yeah,
Probably 4 more weeks.
well, yeah, I should get to you by the end of this week, because I'm trying to catch up with all my. Okay, yes, sir.
Probably when I after spring break, I won't be here that much. I'll be in town.
Oh, okay, but you'll be able to do the test, right?
Yes.
Oh, okay, all right.
Oh, yeah, I'll be here then.
Yeah, okay, all right, no problem. Wow, it's a school hub for me, man.
Oh, yeah, I guess technically it does work better for the dirtiest, because it was the high school.
What's that?
Yes, the dirtiest, because, I think the 23rd, the week that high school goes to spring break.
Oh, I didn't know that.
Yeah,
Oh, okay.
because I just had that for the math class,
Uh-huh.
is that she had pushed off because I think after our spring break, then the high school. goes
Oh,
to
okay.
spring break.
I didn't even, well, I didn't even, the only reason I put it off is because of, the
I just
delay.
think it works out, you know.
Yeah, it works out. The delays that I experienced over there in the, Ocala campus with that building shut down.
And then, so I signed up for the engineering, conference coming Wednesday,
Oh, really?
for Ocala.
Oh,
Yeah.
okay.
Well, because, just besides internships, there's also just, career guidance and, like, school guidance too,
Mhm.
that's gonna happen. And it is, a Fortune 100 company too, that's gonna be there, so.
When is this?
Wednesday.
Oh, I didn't hear about that.
Yeah, I got an email, at least from CF about it, so.
Hmm.
Any recommendations, you think?
Like what?
You think maybe just business casual?
Oh, I would go business.
Oh, yeah.
Yes, I would recommend the going business, that's probably the best way. So it's like, do they have different companies coming and setting up booths?
I think it's just the one.
Oh,
company,
okay.
Cause it's, I think it's a big, just like Kimberly Hone,
Oh, okay.
engineering info session.
Hmm.
Explore the diverse field of engineering, learn about internships and career opportunities.
Oh, internships.
Connect directly with the company's development services team,
Oh, cool.
and there's free pizza.
Well, of course. Have to have some food.
I got luckily the class that I was supposed to go to on Wednesday, went out meeting Wednesday.
Oh, okay,
That I wouldn't have been able to attend if it was.
right, yeah,
Cause it's again all the way in
got
Ocala,
it, yeah.
but.
Well,
Yeah,
yeah, I would recommend business for sure.
Yeah,
You want to be impressive.
yes.
Well, let me sign this off here.